Hello class, we're about to start Unit 4, Topic 7, Slope as a Rate of Change. If gasoline prices went up 25 cents over the course of 2 days, estimate how quickly gasoline prices increase per day. So we have here that it went up 25 cents and then it was over 2 days. So we have up divided by over. So it was 25 cents over 2 days. Now, when we divide this out, this would be 12.5 cents per day. And that is the increase. Now, you don't have to put the 1 day here. You could just leave it as day, but it's per 1 day. Okay, next. Example 2. If a patient's temperature went from 104 degrees Fahrenheit at 11 a.m. to 98 degrees Fahrenheit at 2 p.m., estimate the temperature change per hour. How do we show that this was a decrease in temperature? Okay, so we add a temperature divided by the hours, or hour. And that's equal to, we have the temperature was 104 minus 98 all over 3. But we would make this 3 negative just to indicate that it was a drop in temperature. We could have did 98 minus 104 over 3, which would indicate the drop in temperature as well. So we have 104 minus 98, which would give us 6, divided by negative 3, which would give us a negative 2 degrees Fahrenheit per hour. So that means it went down 2 degrees per hour, 2 degrees Fahrenheit per hour. Now the slope as a rate of change. The average rate of change of y with respect to x is the ratio change in y over change in x. So that'll be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And we also would need to divide these values. Now remember, the average rate of change needs to be written as a unit ratio. Gordon's new car has a 16-gallon gasoline tank, and he wants to estimate its mileage, a rate of change of miles per gallon. He notices his tank is 3/4 full at the start of his trip, with his odometer reading 624 miles. After arriving at his destination, he sees that his tank is now 1/4 full, and his odometer reads 849 miles. Write 2 ordered pairs to represent the start and end of Gordon's trip. Let X be the amount of fuel in the tank at a specific odometer value Y. So we start off. We must first look here. It says that it started off at 3/4 full. So remember, his car takes 16 gallons of gas. So we need to go off here to the side, or we could take our calculator. And what we would have here is we would take 3/4 and then multiply that by 16. And that would give us how many gallons he starts with, which is 12. So we would have 12, comma, and it's 624 miles. That's our first order pair. Now the second order pair, we see that the tank is now 1/4 full. So we would take the calculator, take 1 divided by 4, multiply that by 16, and that gives us 4 gallons. So we know we would have 4 gallons. And then it says the odometer reads 849 miles. So it'd be 849. So these are the 2 ordered pairs. Now it said calculate Gordon's gasoline mileage for the trip. Explain how this is really an average rate of change using the ordered pairs you found in part A. Okay, so now we would take y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we add a slope. Y sub 2 is 849. Y sub 1 is 624. Divided by x sub 1 x of 2 is 4 minus x of 1 is 12. So now we will add 225 for our numerator and negative 8 for our denominator. And when we divide this out, this will give us a negative 28.125 miles per gallon. So basically what we're doing as we travel, we're losing 28.125 miles for every gallon that we're using. That's why it's negative. Okay, because as you know, as you drive your car, you lose gasoline. So that's why it's indicating a negative value here. Now we come here to example 4. Knowing that a linear equation has a constant rate of change, decide whether each of the following tables represent a line. If so, find the slope of that line. Now remember, in order for it to be a line, the slope must be consistent. So if you notice here, we have 0, 1, 2, 3. So they're going by ones. So our y value should be consistent, either going up or going down at a consistent rate. So negative 10 to negative 5 is a positive 5. Negative 5 to 1 is a positive 4. And 4 to 4, well, negative 1 to 4 also would be a positive 5. So this is not consistent, so it's not a line. Now next we come here. Now if you notice here, the x's are going up by 3, which means, because from 1 to 4 is a positive 3, from 4 to 7, so I write that this is plus 3, this is plus 3, and this is also plus 3. So your y value should be consistent as well, because all of these are going up by the same amount. From 5 to 7 is plus 2, 7 to 2 is negative 5, and 2 to 9 is 7. So we know this is not a line. Now we go here, 0 to 4 is 4, plus 4. 4 to 8 is plus 4. And 8 to 12 is plus 4. So these are consistent. The x's are consistent, so the y's must be consistent as well. 5 to 2 is negative 3. 2 to negative 1 is negative 3. And negative 1 to negative 4 is negative 3. So this is consistent. So it is a line. And then the slope, we know, would be negative 3/4 because it's a change in y over the change in x. So it also asks, they want us to find the slope, so the slope would be a negative 3/4. Now I don't know if they wanted us to write out the equation, which I don't see here, so this is the final answer. It is a line and the slope is a negative 3/4. Now it says, note, in the table of values for a linear equation, if there is a constant increase or decrease in the x values, then there will also be a constant increase or decrease in the y values. The rate of change is the ratio of these two. Furthermore, for any linear equation, as the x value increases by 1, the y value goes up or down by the slope amount. So, a person earns a starting salary of $30,000 at a company. Each year she receives a $1,500 raise. Let y be the person's salary in thousands of dollars after she has worked at the company for X years. Be careful of the units. Okay, now it says A. What is the slope of the linear model that describes the situation? What does it mean? Okay, so basically, this person gets a consistent increase of $1,500 per year. So, when we divide this out, so basically, they said that this is in thousands of dollars. So we have to convert this 1,500 to reflect in thousands of dollars. So it'll be 1.5 over the years. Because remember, this is considered to be in thousands of dollars. So next, it says, what is the y-intercept of the model? The y-intercept of the model would have to be the $30,000. So it'll be the order pair is 0, 30. And then what this means is the starting salary is $30,000. That's what that means. Now we go here to C. It says write the equation of the linear model that predicts her salary for any given number of years work. Okay, so we know our slope-intercept form is y equals mx plus b, and we have our slope, which would be 1.5, and we know that stands for 1,500 x plus the $30,000. And this is our final answer. Now, one other thing I want to say to you, just in case you encounter this situation. If it didn't say in thousands of dollars, then what would end up happening is you'd have to write this out as y equals 1,500x plus $30,000. That's if it didn't say in thousands of dollars. But since it did, then we could just, then we're done with this equation here. But I just wanted to show you that. Okay, now we can go here to topic 8, manipulating linear equations. Reminder, algebraic manipulation is sometimes necessary to turn an equation into a friendlier slope-intercept form y equals mx plus b. Don't forget the most basic law of algebra. Whatever you do to one entire side of an equation, you must do to the other side of the equation. Example 1. Determine the slope and y-intercept of the following linear equations by first manipulating them algebraically. So we're trying to get y by itself. So we would add 4 on both sides. Y is equal to negative 2x plus 4. And that will be the final answer. Here we're trying to get y by itself. Divide each side by 2. Y equals 3x over 2. Or you could write it as 3 halves with x in the middle. 3 halves times x. Now, we go here. Determine the slope and y-intercept. The graph, then graph the equation. So what we should do here first, let's use the manipulation to get y by itself. So we'll subtract 2x on both sides. We have 5y equals negative 2x plus 15. Divide each individual term by 5, because remember we're trying to get y by itself. So y is equal to a negative 2/5 x plus 3. Now, since we have this in y equals mx plus b form, we know our slope is a negative 2/5, and our y-intercept, or our b, is the ordered pair of 0, 3. So that could be the first point that we put, which would be 0, 3. And then what we could do is we could use this slope here. Negative 2, remember this is rise over run, so we would go down 2, and then we'll go to the right 5. That'll be our next point. Now we could reverse this, because this could be written also as or 2 over negative 5. So we could go back to this point, and we can go up 2, and then 5 to the left. And then we will have our line. Now I know that these points have disappeared, but you can go back on the video and see these points. It'll be here, and it'll be here. And then you can connect the points. And I know I'm not doing a straight line. It's hard to draw with this pen, but you all get the idea. Well, I redrew the line here to show where these points intersect to give a better visual representation of this. So this is the end of topic 8 as well.